Ready?
Everybody, thank you so much for coming to our combined Pinecone, Databricks, and Fivetran webinar. I'm building a real-time RAG. We'll be going through a few things around Pinecone, how it works, how embeddings work, talk about Databricks and their model hosting, and then we'll get into the meat of it, showing how to use Fivetran to pull data from a data lake, process it through Databricks, and use Pinecone for retrieval augmented generation. So I and my fellow panelists here, the QR codes at the bottom are our LinkedIn profiles. So I'll leave this here for a moment for anybody that wants to scan that to connect, or we're happy to connect with y'all and answer questions offline. My name's Corey Waddingham. I'm a partner engineer here at Pinecone, and I work with our partners like Fivetran and Databricks, primarily around integrating their systems with Pinecone. And Kelly, we want to tell the group a little about yourself.
Yeah, thanks, Corey. Hey, everybody. Kelly Coleffel here with Fivetran. I've got partner sales engineering for Fivetran, working with great technology partners like Databricks and Pinecone. We also work with consulting partners. Really excited to be here today. Corey and Prasad and I have demoed a lot together over the last, I guess, couple of months, and this is kind of the culmination of that. Looking forward to showing you what we have today. Hopefully it's something you can use practically in your day-to-day. Prasad?
Hey, thanks, Kelly. Prasad Kona. I'm a partner solutions architect at Databricks, focused on supporting ISVs. I work very closely with Fivetran and Pinecone. Pretty excited to be here.
Awesome. Thanks, guys. All right, let's go ahead and move along. So when we're talking about RAG and Gen AI in general, one of the topics that is at the core of that are embeddings. So we wanted to find right off the start, what are embeddings? And embeddings are a numerical representation of data, and they capture the essence of that data, whether it's images or video or words or documents. A vector embedding allows us to represent it in a way that computers can understand, because computers don't think in words or images like humans do. They think in numbers. So in order for an AI system to make sense of words and pictures and audio, we need to convert it in a way that it can understand, and that is what embeddings are. And when we talk about embeddings, you'll often hear people talk about dimensions and dimensionality. So just to try to visualize what dimensions are, you can use an analogy of an airplane. So an airplane has 4 dimensions: altitude, latitude, longitude, and time. And of those 4 dimensions, you know where the airplane is in a space-time framework. And you can use the same dimensions with another airplane to compare where they are in relation to each other. In essence, how similar they are, how similar their flight paths are. And it's the same thing when we're running a query against Pinecone or another vector database. You're using an n-dimensional space to see how similar 2 objects are, whether it's chunks of data or images. It's the same kind of math, it's just more complicated. It's a difference of degree, not kind. So as I said, embeddings that are very context sensitive. They're created by embedding models that have been trained on an existing corpus of data to look for commonalities, to look for the weights of words and tokens in a given piece of text. And this allows the embeddings to then carry that kind of context through on future text or future data in the same way. So you don't have to memorize everything right now, but the important parts are that the vector is a list of numbers that tell us something about something. Vector space is the environment in which those vectors exist. And semantics is a study of meaning communicated through language. So an example of how all this ties together is the word bank. Depending on the context, the word bank can carry numerous different meanings. You can ask, where is the Bank of England? Or where's the grassy bank? Or how does a plane bank? because these are all different uses of the word bank, they're semantically different. So they're semantically far apart in a vector space. Meanwhile, you could have words that are very, very different individually, but when strung together in a sentence, they're semantically similar. So the example here is the bees decided to have a mutiny against their queen, and flying, stinging insects rebelled in opposition to the matriarch. So again, queen and matriarch, not that close. Bees, flying, stinging insects, somewhat close. But when you structure the sentence together, the semantic meaning of the sentence, however you phrase it, is essentially the same. And so those embeddings are going to be very close together in the vector space. So we can, again, we can visualize embeddings where you have, the days of the week with their own values compared to all the other data that you have stored, right? They're going to clump together in a geometric cluster, whereas everything else is, is further away and less similar. All right, so let's have some fun, some word arithmetic. And this is one of the interesting side effects of using numeric representations of this kind of semantic data. So you can actually do this kind of math on it, where you take the word king and you subtract man, the value of man, and add the value of woman, you get queen. Like in human language, that doesn't really make sense. That's not really the way those words work, but it is the way that semantic representation works. So if adding the vectors associated with the word king and woman while subtracting man, it's essentially equal, right? You're creating a new vector that has the same representation or nearly the same representation as the word queen. Similarly, you can do the same thing with, capitals. You have the nation of Paris, or sorry, the city of Paris, subtracting the nation of France, adding the nation of Poland, and you get Warsaw, because the semantic representation of Paris in this context is that of a capital city. So that semantic representation carries through. Even when you subtract the nation and swap out a different nation, the semantic representation of capital city carries through. You end up with the city of Warsaw. We talked about proximity. We're going to go into a little more concrete examples of this, right? So here we have a selection of essentially random words: coffee, hospital, music, restaurant, school. They don't really have anything in common with each other. Coffee and restaurant, maybe hospital and restaurant, coffee and hospital, maybe. But generally, these words are very separate and distinct from each other. So if we generate a larger list of words, we can then compare it against the original list to see where the similarities are. So in this case, if we focus on the word coffee, the words like cup, caffeine, morning, those are going to be clustered closer together semantically because they are related. The training data for the original embedding model would have seen those words in close proximity to each other, so they would have had similar values. All right, Prasad, I'm going to turn the show over to you. Please just let me know when you're ready to advance, and I'll click through for you.
Yeah, sounds good, Corey. Hey, and so I'm going to just step back and just talk a little bit about Databricks and the Databricks data intelligence platform, right? At Databricks, our mission has been to democratize data and AI, so that enterprises can get faster insights and value from their data. We are recognized by.
My mistake. You paused. I thought that was my mistake.
Yeah, I'll give you a bigger cue.
Yeah.
We are recognized by analysts to be a leader in both cloud database management systems and data science and machine learning. Original creators of multiple open source projects like Spark, MLflow, Delta Lake, Unity Catalog, and foundation models like DBRX. And so, Corey, next slide. So as in many organizations, like what you see is like data, and the teams that work on data are often logged in their own silos. They they end up using a disjoint set of systems. Like, say, for example, uh, for the data warehouses on one hand and data lakes on the other to do various data tasks. This makes it very difficult for one to discover insights and innovate quickly. At Databricks, we created the Lakehouse architecture to solve some of these problems. All data is stored on low-cost cloud storage in an open format. And so it is stored on whether it is AWS S3, ADLS, or Google Storage, right? And so it's cheap and cheap data lakes. The data is unified under this open management layer to provide reliability, performance, and open data sharing. Corey, next slide. So on top of this, we have the Unity catalog that provides a single unified security, governance, and cataloging for all of your data and AI assets. Yeah. Can you click and advance? So on top of this foundation, yep, we can go to the next slide, Corey.
Okay.
On top of this open Lakehouse foundation, we support all of the various various use cases to support your data and AI workloads. We have Mosaic AI, which provides end-to-end ML AI ops for both generative AI and classical AI. We have notebooks that provide scalability around data science, where you can use the language of your choice and create your jobs and workflows. We have Delta Live tables that simplifies real-time streaming and ETL. Workflows that helps with orchestration of your data pipelines and jobs. Databricks SQL offers the most performant data warehouse out there in the cloud, right? And last but not the least, we have AI and BI is a business intelligence layer that deeply integrates with Databricks SQL and helps with all your BI use cases. Next slide. And so I'm just going to focus a little bit on the platform around how we can build AI agents. Databricks Mosaic AI provides the complete set of tools that you need to create AI agent systems or RAG-based applications. Just to call out a few key components, we have model serving that enables you to deploy not just your classical models, but also agents, chains, or LLMs. One can use foundational models via API, or even deploy your own foundational models on model serving, or even fine-tune existing open source models based on your own data. On top of this, we also have an AI agent framework that further simplifies how you can actually build and operationalize the AI agent systems, like what we're going to demonstrate today. A simple one that we're going to demonstrate today. It's all the way from how you're going to prepare the data, building these agents, fine-tuning them, deploy the agents, and do the entire end-to-end ML ops around these, being able to evaluate, use LLM judges, and improve the performance of these particular models. And finally, when you go to production, you need things that you need to govern, right? For example, AI guardrails, being able to monitor. We provide end-to-end capabilities around that. Go to the next slide. And so in today's session, we're going to go through a detailed demo on how to build a simple RAG application using Fivetran, Databricks, and Pinecone, right? And so I'm kind of like first going to describe what exactly is RAG. RAG stands for Retrieval Augmented Generation, right? It is basically a generative AI application pattern that is used to enhance outputs of large language models, right? By incorporating information and context that is relating to you, for example, which is basically your knowledge base, right? And so when Corey mentioned talked about embeddings, your knowledge base is basically broken down into embeddings, and this is what is used as part of the RAG workflow, right? But before you start, like the first step of to building any of these applications is data, right? Typically in enterprises, data is logged in various systems, whether it is databases, applications, file stores. It can be structured, unstructured, and in various formats, right? Fivetran is one of our closest partner who can help very easily extract this information from these various systems and just ingest it into the lakehouse. And so that's usually the first step that you're going to do when you're trying to build whether it's a chatbot or a generative AI application, right? Next, on Databricks, one can prepare this data, transform it, like say create these embeddings that are needed, and then insert it into a vector database like Pinecone. And this would be the first step on how you would implement. Next slide. Go ahead. Now I'm going to describe you the second step, which is basically like the end user flow, right? The end user interacts with, think of it as whether it is through a notebook or a UI or a custom application. This can be either running in a notebook, your own custom application, or you can create your own custom application and deploy it to a Databricks Lakehouse apps. You can have any of these options. So that when the user interacts, the application takes the user input, and then does any processing as required. Next, it basically calls an embedding model so that it can actually create these embeddings. These embedding models can be are something that are available on Databricks model serving as foundation models, or you can use even external models. Then we implement a retriever that can basically send the embeddings for this question to the Pinecone vector database, be able to do a similarity search to get responses which are in context to what you're trying to ask for, right? So once you get these results back, the next step is to kind of like once you have this relevant content, basically you're augmenting the request that you're going to be sending to the LLM, right? Instead of just saying, LLM, just, hey, this is a question, give me the answer. You're actually sending context related. For example, if you were to have if you're looking at some vector, if we have documentation or customer requests that are actually like information that's there on the vector database, you're able to query this information, and now the LLM knows much more information when it's trying to formulate its response. And so these results from the vector database, enhanced with any other additional information that you have, is then passed to the LLM as part of the prompt. Now the LLM, having the context, will provide you a much better response. Again, this response is again processed by the application, and then we return it back to the user. So as we go towards the demo a little shortly, we'll actually go through all of these steps that I kind of like just described. Now I would like to pass it on to Kelly to focus on how we can get how Fivetran can help get this data that we need to power this application.
Yeah, thanks, Prasad. Usually when I ask, sometimes I'll do a poll on webinars like this, and I'll ask, how many of you have heard about Fivetran? And maybe a hand or two, but in case you haven't, think of Fivetran like Prasad and Corey were both talking about front end of the process. automated data movement platform for virtually any data source out there into the Databricks data intelligence platform. We are not a startup, been around for 12 years now, 6,000 plus customers across all industries and all geos, all sizes, and really have been partnered very, very closely with Databricks over the years, Partner of the Year awards, and really happy to be working with Pinecone right now too. In fact, what you'll see today in this demo, we've been showcasing, I guess, over the last 4 or 5 months at Data and AI Summit, and then also at Microsoft Ignite and AWS reInvent as well. And if we slip over to the next slide there, this is what we're going to do today. It's a little bit of a simplified version, I guess, of what Prasad showed earlier. But think about the types of data sources that you have in any of your organizations. You've got databases. You've got all types of applications out there: Salesforce, Workday, ServiceNow. You've got file systems, eventing systems, and even if in the Fivetran 650 plus data source catalog, maybe there's a source that's not there. We've got a really nice way to develop custom connect, Python-based custom connectors, and have all of that deployed automatically with Fivetran and managed by Fivetran. So think about Fivetran as taking the hard work out of the equation for you when it comes to data pipelines. Hopefully you can shift your data engineering time and your application development time downstream into those higher value activities around developing those use cases, developing those workloads with Pinecone and within Databricks. So we'll show Fivetran moving a data source into the Databricks data intelligence platform. We're going to use Pinecone Vector Database in conjunction with Databricks Unity Catalog, Databricks Compute, Databricks Storage, and Databricks LLM serving endpoints to essentially create a RAG-based Gen AI application that's a travel assistant. In fact, on the next slide, this will give you a little view into it. Prasad, Corey, I mean, we've done a lot of talking. You want to jump into the demo now, maybe?
Yeah, why don't I stop sharing and pass the controls over to you, and you can show us how how Fivetran gets the data into Databricks, and we'll go from there.
Let's do it. We'll go end to end here. All
And we're going to do
right.
it live.
That's right. That's right. No video demos here. Everybody see that okay? It looks like it's showing up. Should be a Fivetran UI. I've got Fivetran, I've got Databricks, I've got Pinecone, all the key technology stack is there. So if you haven't seen Fivetran before, this is it. And you could say, oh, well, this is interesting. Got a lot of different connectors. Even on this page, you see a little bit of SAP, Oracle, Salesforce, SQL Server. Say, hey, I need to add a new connector. The first thing to me that stands out, and I've been here, it'll be 3 years, I guess, in a few months, is the number of sources. When I got here less than 3 years ago, we were probably around 200 or so. So you see a lot of sources being added in, 663. So those go across virtually any database, application, file system, event system. But if you say, hey, I got this Kelly application. My name's Kelly. I got this Kelly application out there. Wait a minute, Fivetran, I don't see that out there. Well, you got a couple of options. You could build a light connector with us, submit an easy form, take a look at that particular application and say, yeah, we'll build a first-party connector for that we'll support, provide it to our entire base. Or we now have that connector SDK that if the light connector is not something that is going to work, then you can build very quickly with templates that we have, Python-based templates. You can build a custom connector for this Kelly application. Today, we're not going to look at the Kelly application. No, SAP, no. Oracle, a lot of options there. No, we're not going to do that. SQL Server. We're going to go, I have got a California wine country database. It's not huge. It's got about 743 wineries and vineyards in it across all of California wine regions. There's probably 2,500 total, somewhere in that range. So this represents roughly, I don't know, a third or so, maybe a little bit less than a third of those, but it's a good amount. That data set, that database sits out in Google Cloud, PostgreSQL. So we want to go grab that data set today because that's going to form the foundation for this Gen AI travel assistant that we're going to create. Fivetran you go, okay, well, Fivetran's going to pick up data from Postgres and move it into the Databricks Lakehouse. And you have a lot of different ways to do that. I'm going to use Databricks, this particular destination, which I've named Databricks Unity Catalog Serverless. You saw Prasad talking about support for Iceberg, obviously Delta, Parquet files. Fivetran does all of that as well. You really have a lot of options when you're working with Databricks in terms of the destination support. And I'll come back.
Kelly,
I'll show you.
Sorry, if I may, one of the things I like about using Fivetran for this is because you do have so many connectors. Once you have the later part of the pipeline set up, if your data source changes, you don't have to recreate entirely from scratch, right? You just change which connector you're using and point it to a different data source, but the rest of the pipeline remains essentially in place.
Yeah, great point, Corey. And that's something too that again, even if that data source is not there today, you could build really quickly a connector to a custom source. So this is the database setup page. You see this setup guide over here. You got all the documentation. I like one of my colleagues says, we have 650 plus setup guides. Every setup guide is unique to that source. And you notice here, I put in, while Corey was explaining, I put in a travel assistant as my destination schema prefix. Now, I don't need to go out to Databricks. I don't need to go out to my Unity catalog and create tables and columns and schemas and all that kind of stuff. Fivetran is actually going to do all of that for you. It's going to do all that schema creation and management. And on top of that, handle all the changes that happen in the source, persist those over to Databricks data intelligence platform automatically for you. So that's terrific. I want a schema prefix, though. We'll call it a travel assistant today. And when I go knocking, when Fivetran, I guess I won't, but when Fivetran goes knocking on that PostgreSQL door, we need to be able to authenticate. So I've got a host identifier, I got a port number, user ID, password. I do have multiple databases in that Postgres instance. We're going to go after the industry database. And I got a lot of different ways that Fivetran allows you to connect, especially with relational databases like Oracle SQL Server, DB2. I can connect direct, SSH, reverse SSH. I can go Azure Private Link, or I can use a proxy agent to do an outbound connection. A lot of different ways to make that happen, depending on your operational or networking or security requirements. Similarly, we usually have multiple methods to connect to a relational database environment or not connect, but to detect changes within a database. In this case, I'm going to use a logless change detection mechanism called Fivetran Teleport Sync, but I could go XMin, I could go WAL. If this was Oracle Log Miner, I could go against the binary log. Same kind of thing with SQL Server DB2i. So let's save and test that. And with Fivetran, one of the things you can be assured of is we put security first and foremost. In fact, if I didn't have a TLS certificate on that Postgres server for this direct connection, it'd kind of be demo over. We wouldn't be able to go any further. The reason that's important, that TLS certificate for direct connection, allows us to encrypt any and all data in motion all the way through the process. In fact, once we've moved the data into the Databricks Data Intelligence platform, all we do is maintain a cursor to that last checkpoint. Once we move the data over, we don't store anything. That's Databricks' responsibility at that point. So on the backside, we've essentially initiated that connection to the Google Cloud PostgreSQL instance. Let's continue on. And based on those credentials now, you saw we want that industry database. We had those other credentials. Postgres is going to say, okay, Fivetran, you have access to these 13 schemas. Now, I can block any of these schemas, any tables that I want. In fact, I think I'm going to turn all of those off. I'm going to go with the agriculture schema because remember I said we're going to do a wine country travel assistant. Here's that California wine country visits table. That's really the only one I need for this particular application. You see this little filtered data box that pops up. That's kind of interesting. It's actually a relatively new feature for us. If you want to filter data and really define what you want to include in your initial sync, let's say I want to take, information that was created between January 1st, 2024 and November 1st, 2024, I could do that. So I could filter that at the column level, put the operator on that I want, I'm off to the races. So that's kind of cool. The other thing is when you look at the columns that are sitting in this California Wine Country Visits table, and I hover over, for instance, the address, I get this little hash. You say, what's that? Well, if I've got a PII column that is fine in my Postgres database or Oracle database or Salesforce application or Workday application, but I don't want that PII persisted into my Databricks platform, I can hash that at the column level. I can still use that column because I'll maintain a key, but the information is hashed. So that's cool as well. Again, privacy and security, very, very important. Let's save and continue. And then lastly, I think I've talked about this, but CDC is automatically set up for you. So we're going to allow all new schemas, tables, and columns to persist over into Databricks as Fivetran goes out at the schedule that I choose to take a look for any changes that have happened in that PostgreSQL database. You can see I started the initial sync. If I go up to the setup page, Fivetran is going to default me to, again, I call it knocking on the Postgres door every 6 hours saying, what do you have? Do you have any changes for me? I can move that all the way down to 1 minute. I can make that as lengthy as 24 hours if I would like to. So that's all cool. I can come back. I can update schemas. I can add to this if I want, but that right there, that's about as simple as it gets to connect to a database. And I guess the 6 years or so I was in consulting, data consulting prior to coming over to Fivetran, the things that I heard more than any other were, Kelly, I need my entire data state, but especially on this data movement side, I need simplicity, I need speed, I need self-service, I need scale, I need security. All those kind of things that are operational reliability, that's where you can start thinking about shifting downstream your data engineering time, your application development time from data pipeline kind of Band-Aids and baling wire and duct tape to doing really cool stuff downstream with Pinecone and Databricks. So our travel assistant connector, remember we called it a travel assistant connector, is going from Google Cloud to Databricks Unity Catalog Serverless. The last thing I want to show you, and we'll jump over to Databricks, I want to show you this destination real quick. It's our Databricks Unity Catalog destination. And you can see it's pretty easy to set up. We're actually moving data over to Databricks in Delta format. Kind of the typical things you would imagine. We're using Unity Catalog as well. That is my Unity Catalog name for this destination, TS Catalog Demo. And we're actually running this in Azure. Obviously, Databricks supports Azure, AWS, and Google. Same thing that Fivetran does as well. So let us head on back over and see if we've got a connector here. There's our travel assistant, and there it is. So that's our travel assistant. Remember that name. I need to remember it too, because it's going to come into play later on. There's our initial sync that is done. So that's now sitting in that Unity Catalog, TS Catalog Demo in Databricks. Let's jump out to Databricks, TS Catalog Demo. Let me refresh this. Let's do a refresh. And voila, there is a travel assistant with that extension of that agriculture schema. There's our California Wine Country Visits table. And here is, well, there's your columns there. You can see there's about, I don't know, 27, 28 columns. Ooh, by the way, I don't know if anybody else, if there's any Databricks users out there, I love these descriptions. I've found that when the built-in AI in Databricks said, hey, here's a suggested description for this table. It's really good. I usually just hit the accept button on those. I like this. You can do the same thing. You can have Databricks generate tags for your columns, all kinds of stuff. So very, very cool. Here's that sample data though. Here's what we just moved over. I've got the winery or vineyard name. I've got the wine region, all these different. These are my column headings up here. Here's the data in each of those rows. Let's come over here all the way over. I probably have a yeah, there's my Fivetran synced and it was just done, probably UTC time, but there we go. That is your raw data. Now, this is sitting in the Databricks bronze layer. It is very usable. It's very understandable. We can work with this data. A lot of times people ask me, say, Kelly, what does Fivetran do differently for Gen AI? I kind of look at them, I go, well, nothing. Doesn't matter what your data workload is or your data outcome is. You need high quality, trusted, usable data, persisted over and over and over with all the changes automatically into Databricks, and then Databricks can work its magic. All right, so we've got our bronze, we've got our raw. Let's go out to get the data transform. Now, I want to set my context here. Here's my catalog. Right now, I've got this set on a schema that is all day to Databricks. I like that. But our schema name was a travel assistant. That's the data set we just moved in. Let's run this. And while this is running, think about when you're building Gen AI applications, generally, you don't want to run embeddings on, I found anyway, you don't want to run embeddings on structured data sets. You really want unstructured data. And so one of the things that we kept thinking about is, man, we've got so many incredibly rich enterprise data sets sitting in databases or sitting in applications, but a lot of it's in structured format. How can we turn that into something that's LLM friendly? And for this data set, we did something really simple. You see this concat function here on each of those for that that we're running against that that particular table. We took and had a little prefix, like the winery name is, the wine region is, the price range. Like we wanted to turn these columns, these 27 individual columns into an unstructured document call or a new column, winery information. If I look at this now, here's what that concat with those prefixes has done. It's taken some, you know, a great data set, but a structured data set, and now I have essentially an unstructured document. That's pretty cool. So that's one thing. That's the first piece of that transformation that we're doing there. Now the second piece of that is,
Kelly, if I may, just to call back to earlier in the presentation, if you recall, I was talking about, you know, 3 uses of the word bank, right? The word bank can have multiple meanings depending on the context in which it's used. And that's the same thing that's happening here, right? For example, continuum of state just by itself could mean anything, right? It could be a winery. It could be a piece of land owned by somebody from the Q continuum in Star Trek. Continuum of state doesn't contain a lot of semantic meaning to it on its own. But when you add the winery name is continuum of state, well, now the embedding model has something it can work with, right? It has more semantic information that it can render a more accurate embedding value for.
Great description. Corey, further to that point too, when we're I know you and I talked about this, and to get the best accuracy, you said, Kelly, what Pinecone really wants is put this winery information into a JSON format. So if you look at the second piece of the second transformation, if you will, that we ran in Databricks, was we created a metadata column that's essentially the same thing as you see as winery information, except it's JSON format. So that's going to just dovetail perfectly into, and that's going to be the column that we use. That's going to dovetail perfectly into Pinecone embeddings being run against this particular data set.
Yeah, and I just want to add here, Kelly, I think it's Yeah, I know we just took this simple data set for this demo, but think of it this way. As an enterprise, you might have some data, say, for example, tickets and ServiceNow or something like that. You can get that text from for these various tickets, you put it as metadata, and then insert that into create embeddings and insert that into the vector database. That's where the power of what this architecture would provide.
Prasad, that's a great point, man. When you think about a lot of the applications that you have out in there, ServiceNow, Salesforce, Zendesk, Slack, a lot of these things have rich textual information that's kind of embedded in a structured or semi-structured format. One of the things that we're doing too at Fivetran, we're creating some really interesting data models right now to automatically create that LLM friendly or embedding model friendly data set in Databricks against those typical sources that you would want to use. So that's a great point that you made. Okay, so think about it. You think about the medallion architecture. I go bronze, silver, gold. So we had our bronze sitting in our raw data. Now I kind of consider us at silver now. Now we want to go to gold. So we've got our transform data. Let's go out to a Databricks notebook. I've got so many things going on in Databricks here. Here's what I'm gonna do. I'm gonna hit this run button to get everything cranking. And while that's going, I want to show you what we did for this. So this is what we've been demoing at Ignite and in reInvent and Data and AI Summit. So we've got obviously some preliminaries up here. We're running config utils, loading, installing the libraries, etc. I do have an area here. I know Prasad, you didn't like the way I did this. I will try to adjust that later on. You wanted me to do the variables up at the top. I love that. I just didn't have time to do it. I bet I'm getting prompted. Yeah, I am. So right here on my fourth cell or the step 4.3, I'm saying, hey, we want to make sure that we're using the most recent data that we just put in. We're using that data set. We call that a travel assistant. And then our Unity catalog was TS catalog demo. So that sets our context for the rest of this notebook. And you can see this next step, which is really interesting. This is where we're loading the data from this new data set that was put into Databricks, and we're creating the vectors in Pinecone. And I'm going to go through this. And Corey, I'd love for you to step through any highlights here, especially as it relates to creating the Pinecone index. We're using cosine similarity search, all those kind of things.
Yeah. So what's happening behind the scenes is, you can see that Kelly's using the serverless spec. So it's creating a serverless index in Pinecone, configuring it to use 384 dimensions to go along with the embedding model that we'll use later, specifying which cloud and region it's going to be hosted in. Yeah, and then once it actually loads the data, it needs to get the actual embeddings, right? That's where the meat of the transformation is happening. So it'll go through first, create a pandas object that will hold the original data, and then step through it and create in vector embeddings for each one of those blocks of text that Kelly showed before. Like for the Continuum winery, the winery name is Continuum. It's in the I forget which AVA it was in. It's in, such and such AVA. All of that is considered a single chunk of text because it's relatively small amounts, right? It's, less than 1,000 characters, easily handled by a sentence transformer, easily handled by the embedding model. No need to really break it up any smaller than that. If you are working with a more, let's say, a more complex data set that maybe had pages and pages of text, you may want to add a chunking strategy here where it would chunk on either on paragraphs or on a probably not per sentence, that'd be a bit much, but on per paragraph or even per page, depending on the amount of relevant context you want to make sure is captured in each chunk. And that's going to be very situationally dependent. We generally recommend paragraph.
That's a
basically.
great point. And I did see a question as you guys were talking earlier. We did not have to chunk this up at all. Those unstructured docs that we created were small enough where they were that wasn't required.
Right,
Yeah.
right.
And I think it's when you're actually creating this application on Databricks, I mean, you would be able to use the strategy of how you want to chunk it. Yeah, we have I believe this particular demo is using the embedding model using a foundational model API to create these embeddings. Yeah, and it provides you like the options that you need.
Yeah, absolutely. So we had Corey, you'd also recommended to me kind of a best practice is to batch up these records as they're going through the embedding process, and you'd suggested using a batch size of 100. We have 743 rows, so you can see we had 8 batches that were created. We had a couple of check verification records in there as well. So
Yeah.
I think
there's a very practical reason for batching it as well, and that's simply because and again, less likely to happen with a data set of this size, but keep in mind that, this is running over REST. So there are HTTP limits on the total amount of data that can be in a single HTTP package. So if you're working with large amounts of data, you may need to have smaller batch sizes, right, to make sure that you're staying under those limits. Otherwise, you'll encounter errors with, trying to upsert the data. And if it's very small, then you could potentially use larger batches, but we generally recommend batches of 100. That's usually a safe choice.
terrific. So our step 5, we've got testing out similarity search with Pinecone. You can see our weightings there and how we are doing that. I don't know, Corey, anything that you want to comment on here? You can see the results. We actually had some print results here just to make sure everything was working properly. Anything on the similarity search that you want to call out?
Yeah. Thank you. That's exactly what I want to call out. You'll notice that each of the results is coming back with a similarity score. So this is Pinecone's way of telling you this is how similar what I'm giving you was to the original query. And similarity score it's an important part of any RAG application. Now, in this case, the scores are relatively low, but generally speaking, you'll have similarity scores that are higher. So you may want to, and this would be in the actual business logic of the application. This isn't on the server side on Pinecone, but in business logic of the application, you could put in a minimum threshold of say 0.8. In fact, our legal semantic search application that's available on our Learning Center uses that strategy. So it's looking only for items that are pertinent and close in similarity to the actual query.
Yeah, you're right. We have some business. So this 0.68, if I go out to Pinecone, Corey, and I go into winery embeddings and I go Coleful Vineyards, hit enter. Look at that score.
Yeah.
So this is, by the way, so I jumped out to Pinecone real quick just to show you that. So I can do all types of testing of my similarity search out here. Business logic, as Corey said, everything that we're building out is here in this Databricks notebook. By the way, I'll come right back to this. I got to mention this. I'm a huge fan. If you haven't checked this out yet in Databricks, so if I go out to compute, you got this little apps button over here. Click on that and say, hey, I want to create a new app. Oh my gosh, I've got an app library now that right within Databricks allows me to deploy a Dash, Flask, Gradio, Shiny, or Streamlit application directly from Databricks. So, and you've got these templates already set up for chatbots, data apps, etc. So very, very cool. You can go fully custom as well if you want. I just wanted to call that out because it's a relatively new capability within Databricks, and I personally am really, really excited about. So wanted to jump out there for that. All right.
Yeah, that's really cool. And anything that helps developers get into production quickly, which
yeah, Yeah.
Sometimes just, just the work of building out the framework for the app takes an inordinate amount of time. So if you can streamline that, that's awesome.
Yeah, it's very, very nice. All right, this step 6, I want to show you the application. Prasad talked about this in the Databricks region that I'm running in. I've got access to 4 LLM serving endpoints, and we made those available, all 4 of those available in the application. So I've got Mixtral, I've got the DBRX LLM, and I've got a couple of MetaLlama LLMs as well. You can choose the one that you want based on, how you just try them out, really. What I would recommend, what I've seen best on RAG applications is try out the ones you think will work and then hone in. I wouldn't. This is kind of for demo purposes or lab purposes. Don't give too many options out there. But
Yeah, I think
this
it's like,
section.
I just want to add here, I think it's on Databricks, we have a rich set of LLMs that you can access, and also you can use external models like OpenAI and others. We have a playground where you can actually compare the performance of this application against various LLMs, run various kinds of eval and others. And so you have the entire set of rich set of tools for you to optimize this flow. I mean, for the sake of this quick demo, we kind of like just simplified this, but yes, we do have the capabilities on the platform to enable you to improve the performance of these outputs.
I love the playground too, Prasad, because I can test out at the same time all these different endpoints. Like I could test
That's
out
correct.
how does DBRX perform versus Llama 31405B and 70B. So it's just right here under machine learning. Definitely encourage you to check that out too.
So
All right,
Kelly, we're coming up on 10 minutes, and we got a bunch of Q&A to go through as well. So
Perfect. Let me jump down it. Let's go down to the application and show you what we did. So here we go. Wine Country Travel Assistant. We've got this divided up into different sections, just so you're not watching me type the whole time. We've got some hotkeys here to do a Pinecone vector search on Coleful Vineyards. You can see how fast that is. Coleful Vineyards. I can do a vector search on Coleful Vineyards and Millman Estate. This is coming directly out of that private enterprise data. If you listen to Ali Ghodsi, CEO of Databricks, he says where you're going to differentiate yourself in AI or Gen AI, it's with your data. And to me, that's the power of what we have at our fingertips with Gen AI. When I can use my private data here, there's no Coleful Vineyards doesn't exist anywhere,
not yet,
except in this data set. Did you have a comment, Corey?
No, I was just saying not yet.
Oh, not yet. Oh, yeah. Not yet. Yeah. Maybe one day. We'll see. Okay. So we got this vector search. Then that's cool. Well, what is this down here? Let's skip on down. Let me reset the prompt. Let's skip on down. Generate a 2-day trip plan. This is kind of what you want here. Let me take these control records that sit out of the 743. These only exist in the data set. Think RAG, think retrieval augmented generation. I not only want to do a vector search, use a vector similarity search using Pinecone, but like Corey and Prasad talked about, I want to pass that context over to Databricks, over to those LLM serving endpoints to plan a trip. So this is using Pinecone vector search and similarity search to pass. It goes out, hey, give me Coleful, give me Millman, give me Hernster. It's using the Databricks LLMs. And I'll show you this here in a second. Very specific things around what we want around a trip plan. So let me jump into this and make it a little bit bigger. So one of the things we told the Databricks LLMs that we wanted was, I want a catchy name. I want to be able to impress my wife on this wine country visit itinerary. So it gave us Wine Trek, Sonoma Coast Sojourn. It said, okay, day 1, start your journey at Coleful Vineyards. We also asked and said, we want the top 5 unique characteristics of each of these vineyards. So you can see some of the cool stuff I have at my vineyard that's in that database. I even have a Fivetran hands-on lab where you can build your own Gen AI travel assistant. This is not hallucinated. This is in that data set. I've got a very unique winery with kayak fishing, volleyball, and basketball as well. Same kind of thing, Millman Estate. colleague of mine at Fivetran. He's got some cool stuff like a wall of vintage surfboards. So again, you're getting this RAG-based approach, the power of those LLMs in Databricks, but also this RAG-based approach in that very personalized, private, bespoke data set that Pinecone is doing this similarity search against, that's all driven by Fivetran moving this data into the Databricks data platform. I've got things like cost. These kind of things, tips for making the most of this is what we asked the LLM to do. I want to show you last thing, and then I'll turn it over to you, Corey. Where was our, let's see, I think it may have been in this last section or last cell. I just want to show you what we asked the,
Looking for the prompt.
yeah, I was looking at, because what you want to do with these applications, you want to set the persona. I don't want to have to type in, hey, you're an expert, wine country visit assistant, and here are the 10 dimensions when I plan a trip. We built that in. I probably will run out of time scrolling through right now, but those kind of things are built into this application. You can also take this application, which we've got in a Databricks notebook right now. And remember those Databricks apps that I showed you, Shiny, Gradio, Streamlit, etc. Very easily repurpose that into one of those applications. So I hope this was interesting to you. I'm very, very bullish on what you can do with RAG, with your private bespoke data, to get huge value out of AI and Gen AI. So Corey, Prasad, maybe some Q&A?
Yeah, we've got some really good questions here. I know Prasad's gone through and answered
No,
some.
I
I've
think it's
answered as well.
yeah, I just want to I know that I tried to answer a number of these questions on
Yeah.
the chat. Definitely I want to pick up one of these questions that was asked was, how do I get this from here to actually operationalize this one? Right. And so what you have actually deployed, what you've created here, this RAG application or a chain can basically be registered as a model onto Databricks Unity Catalog, and then you can directly serve this model, right? So for a simplistic one case where we did was Kelly showed you how you can actually just quickly test it in the notebook, right? But an actual application would be like your UI, which is basically deployed either on your infrastructure or on Databricks apps, which can be any app that can be Shiny, Gradio, or Streamlit, right? These apps can be on Databricks apps, and it would interact with the model or chain, right? And Databricks would like Mosaic ML provides end-to-end monitoring of this one, like whether it is not just about governing how it is used, but getting the monitoring metrics, being able to create evaluation data sets so that you can actually further improve the quality of your chatbot. And so you'd be able to do all of that once you deploy this model onto your model serving.
Yeah, I'm glad you mentioned that, Prasad, because it's it's very easy to overlook things like monitoring and tracking metrics when deploying Gen AI apps. It's especially, I know a lot of data scientists that get in Gen AI and they don't have the DevOps background. So it's always good to remind that, yes, you want to make sure that whatever system you're using has that kind of observability.
Yeah, and I think it's the main thing also, right? This observability is across all of these systems that we just talked about. Databricks, the Unity Catalog provides this end-to-end lineage across the whole thing, right? You're talking about how is the data being ingested from where by Fivetran, how the data is transformed on Databricks through the entire your ETL flow, how next, how what kind of embedding models are used, and then how the data is inserted into Pinecone. That's one aspect of it. And then when you deploy this as a chain, you see this application that is actually using this, right? And so you'll see end-to-end lineage metrics that you need for governing this Gen AI application.
Yeah. So there's a couple questions around text splitting. Both Jared Franz and who was it else? Julian Perez Pascual both asked about essentially around text splitting and chunking strategies. Excuse me. And so Julian's question is if there's an effective chunk size. I think the answer is generally it has more to do with the amount of information rather than the bytes of data, if that makes any sense. You know, if a paragraph of data has enough contextually relevant information to be able to provide good context to a model, then a paragraph is fine. But say, you know, let's say you're chunking up, a law, right? And laws love to have bullet points and subsections that might only have like 1 or 2 lines. You're going to need a little more context around that for the model to make sense of that. So it's very situationally dependent, but generally you want to think about not so much amount of bytes of data, but amount of contextual information. You have to think about your data in a different way. Similar to Jared's questions about text splitters. Personally, I tended to fall back on LangChains because I think LangChains recursive text splitter does a great job of maintaining contextual overlaps and overflow. If I'm doing a quick and dirty application, similar to what Kelly walked us through today, then I might just use just simple line by line or just splitting it up via Python internal tools. But I've had a lot of success using LangChains specifically. That's the one I go back to. Kelly or Prasad, do you have any text splitting techniques that you like to use?
I think, yeah, one would be able to, depending on your use case, you should be able to use various techniques. I mean, on Databricks, I mean, whether you just mentioned about LangChain, right? Whether you're using LangChain or Llama Index or DSPy, you'd be able to use any of your the choices to build your GenAI applications on Databricks. And for text splitting, look at these various options these various frameworks provide, and you should be able to use them.
Cool. Okay, we're a little bit over. I think we have time for one last question from Shivi Bhatia. Last question. We're using cosine similarity and not sure which embedding model, but in many cases, cosine is not the best similarity, which is where we use something like Colbert V2, coming from one of the creators of Databricks. What do you recommend to keep size in check if using Colbert V2 because it exponentiates the vector size? I'm not personally familiar with Colbert V2. Prasad or Kelly, have you worked with that one?
I have not, Corey.
Okay. So, but just to take it as a general question of managing size, again, this goes back to the chunking question and making sure you have semantically relevant context on a per chunk basis. Not being familiar with Colbert V2 and why it might increase vector sizes, there may be something more at play there. I think the point about cosine not being best, I think that's valid. I think that cosine is great for finding the angle difference between the two vectors, which is usually sufficient, but not always. A good example is product recommendations are sometimes better served by Euclidean because Euclidean math can take into account individual characteristics of the chunk, like price. It can be a little more precise on numbers and gives a little more weight to those than just the pure semantic meaning, which is what cosine really relies on. So short answer is yes, there are different angles of approach, so to speak. You want to use the one that's relevant for your application.
Corey, we've got some, I guess, some calls to action here to jump out to Pinecone, Fivetran, and Databricks.
Yeah, please.
We just wanted to call everybody's attention. If you want to get started with any or all of the various solutions you saw today, those URLs will take you there. Every one of us has got a free tier that you can use for a certain period of time. So feel free to jump out there, try it out. reach out to me, Corey, or Prasad if you have any additional questions, and happy to engage with you. From a community standpoint, you saw our LinkedIn QR codes there. Feel free to ping us on questions there as well if you want to. Corey, this has been a lot of fun. Prasad, great time with you and Corey both. Really appreciate being invited in, and thank you for everyone for joining in today.
Yeah, Kelly, Prasad, this has been very, very informative. And Kelly, I always love your Wine Country app. I think it's great, and I'm looking forward to the day when we can toast our success at Colorful Vineyards together.
That's right.
Yeah.
Yeah, I gotta get to working on that. I
Yeah.
know what it looks like. So, Prasad, great
Hey.
seeing you today. Thank you for
Thanks,
everything,
Kelly
and
and Corey.
appreciate all the great insights into Databricks.
Thank you, guys.
Awesome. Thank you, everybody, and we'll see you at the next one.
All right. Thanks, everyone.
Bye.
Bye.
Cheers.